we're going to talk about how to use the sum or difference of cubes to factor polynomials. So let's start off with the sum of cubes. Suppose we're trying to factor x cubed plus 8. We know that it's a sum of cubes because x cubed is x to the third power and 8 is 2 to the third power. So we're going to call x a and we're going to call 2b, and we're going to plug into this pattern here. We have a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. So that's how we get the factored form of this expression as x plus 2 times x squared minus 2x plus 4. So in this class, you won't actually have to memorize this factoring pattern, but if you ever do, there's a pattern to the signs that can help you remember it. So this first expression here is going to be the sum of a and b, and that's always going to have the same sign as the original expression. Then we're going to multiply it by this trinomial that has the square of the first term minus the product of the two terms, and that product term is going to have the opposite sign of the original expression, and then plus the square of the last term. And that last term is going to be always positive. Similarly, we have this difference of cubes factoring pattern. So say we're factoring something like x cubed minus 64. We know that x cubed is x to the third power, so we're going to call x a. And we know that 64 is 4 to the third power, so we're going to call 4b. We're going to plug into this pattern, which means we have a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. Once again, we have this SOAP pattern in our signs. So start off with the same sign. This product term has the opposite sign as the original expression, and this last term is always positive. So that's going to give us the factored form of x cubed minus 64 is x minus 4 times x squared plus 4x plus 16. So if you need a reminder of the perfect cubes, there is a chart in the study guide that's posted in the resource folder. Make sure you use that as you're trying to factor these expressions. Another thing I want to remind you of is this important exponent property that we'll be using. If a term with an exponent is raised to another exponent, remember you multiply the two exponents. So if we have x to the fourth to the third power, remember that's going to be x to the 12th because we can combine these exponents by multiplying them. So that's going to be 4 times 3, which is 12. So here's what we're going to do to factor the sum or difference of cubes. Start off by factoring out a GCF if there is one. Check to see whether the first and last term are perfect cubes. Then we're going to determine the values of a and b, and then we'll write the two factors using the sum or difference of cubes. Let's start off with this example. So here I'm trying to factor x cubed minus 125. So x cubed I'm going to call a cubed, and 125 I'm going to call b cubed. So let's figure out what the values of a and b are. So we have a cubed equals x cubed. So what I'm going to do is I'm going to figure out, well, what raised to the third power is going to be x cubed? Well, we know that x raised to the third power is x cubed, so that means that whatever's here is going to be a. So a is going to equal x. Similarly, let's say b cubed is 125. So I need to figure out what raised to the third power is equal to 125. Well, I can use my chart to help me out with that. You can see here that it tells me 5 cubed is equal to 125. So I'm going to say 5, and that's going to be the value of b. So b is going to equal 5. So now I'm going to take this value of a and b, and I'm going to plug into the difference of cubes factoring pattern, because notice this original problem has a subtraction sign in it. And so when I plug that in, I get a minus b, so I have x minus 5 times a squared, so x squared, plus a times b, so x times 5, and then plus b squared, so plus 5 squared. So now I'm just going to simplify this and write this a little more neatly. So I have x minus 5 times x squared plus x times 5, I'm just going to write it as 5x, and then plus 5 squared, that's going to be 25. Okay, so that's the factored form of the original expression. So now let's try this example. Let's factor 8x cubed plus 27. So once again, I'm going to call this first term a cubed, and I'm going to call this second term b cubed. So I have a cubed equals 8x cubed. So I need to figure out what expression raised to the third power is going to give me 8x cubed. Well, 8, I can see from my chart here, is 2 to the third power. Okay, so that 8 is going to be 2 to the third, and then x is going to be x to the third, right? So 2x to the third power is going to give me 8x cubed. So that means my a value is going to equal 2x. Now let's think about b. Okay, b cubed equals 27. So I need to figure out what raised to the third power is going to be 27. Well, if I go to my chart over here, it tells me that 3 to the third power is equal to 27. So I know that the value of b is equal to 3. So here I have a sum in my original expression, so I'm going to use the sum of cubes factoring pattern. So that's going to give me a plus b, so I have 2x plus 3 times a squared, so that's going to give me 2x squared, then minus ab, so minus 2x times 3, and then plus b squared, so plus 3 squared. So now let's just go ahead and simplify this. So I have 2x plus 3 times 2x squared. Remember, when you're squaring something like that, you have to square both 2 and x. So that's going to give me 4x squared. Minus 2x times 3 is going to be 6x. And then plus 3 squared is going to be plus 9. So this is now the factored form of the original expression. So now you can go ahead and pause the video and try doing this example on your own. So here we have 64y cubed minus 125. 64y cubed is going to be 4y to the third power, so that means that a is going to be 4y. B cubed is 125, so we know that b is equal to 5. So since we have a difference in the original expression, we're going to plug into the difference of cubes factoring pattern. So we have a minus b, which is 4y minus 5, times a squared, so that's going to be 16y squared, plus the product ab, so that's going to give us 20y, and then plus b squared is going to give us 25. Now let's try this example. Here I have 27x to the 6th minus 125y cubed. So I'm going to say 27x to the 6th is a cubed, and I'm going to say 125y cubed is b cubed. So 27x to the 6th is a cubed, means I need to figure out what raised to the third power is going to give me 27x to the 6th. So 27, I know, is going to be 3 to the third. I can get that from my chart over here. So I'm going to put a 3 right here in parentheses, and then I'm going to think about, okay, well, my power of powers property backwards, because I know this is going to be x to some power raised to the third, and that's going to give me 6. So I know that I'll end up multiplying these exponents together, so I need to think 3 times what is equal to 6. Well, I know that 3 times 2 is equal to 6, so that means this is going to be an x squared that's raised to the third power to give me x to the 6th. So that means that a is equal to 3x squared. Now let's think about b. Okay, so b cubed is equal to 125 y to the third. So that's basically saying something raised to the third power is equal to 125 y to the third. Well, 125, I know from my chart, is 5 to the third. So I'm going to say 5. And then y to the third means I just took a y and raised it to the third power. So that means my b is going to equal 5y. So now I just take this 3x squared and 5y and plug them into the difference of cubes factoring pattern. So my first term is going to be a minus b. So I have 3x squared minus 5y, and then times a squared. So I'm going to say 3x squared squared, and then plus a times b. So plus 3x squared times 5y, and then plus b squared. So plus 5y squared. Simplify this, I get 3x squared minus 5y times 3x squared means I squared 3 and get 9. X squared squared is going to be x to the 4th. And then plus, here I have 3 times 5, which is 15, and then just x squared y. And then plus 5 squared is 25, and then y squared is just y squared. Okay, so this is now the factored form of the original expression. So now you can go ahead and pause the video and try doing this example on your own. So here I have 343x cubed plus 27y to the 9th. So a cubed is 343x cubed, so that means I have 7x to the third power, which means a is 7x. B cubed is 27y to the 9th, so that means b is equal to 3y cubed, because 3 to the third is 27, y cubed cubed is 9, y to the 9th. So here, when I plug into the sum of cubes factoring pattern, I have a plus b, so 7x plus 3y cubed, times a squared, so 49x squared, minus the product, so 21xy cubed, plus 9y to the 6th. So remember, if an expression contains two perfect cubes that are being added or subtracted, you can use the sum or difference of cubes to factor.